So as soon as our testing system is not available, then okay, we have no other uh, possible solutions as to go directly to our lectures without any initial tests. So let us start. On our previous lecture, we discussed the basics of the formats that we can use to organize the client-server interaction. We discussed such formats as JSON, XML, and their advantages and disadvantages. We discussed that if you choose the wrong format to serialize and deserialize your data, then it can provide significant impact on the effectiveness of your distributed system. It would cause great issues in CPU effectiveness of serialization and deserialization. It can cause significant issues in the data processing and data streaming, because wrong format of data serialization would take more from the network capacity than the standard format, when the good format of data serialization. So the next step from the format, when you choose the format, you need to understand how to organize your client-server system. So one of the core problems and one of the oldest problems in information technologies that was highlighted by a lot of professors and a lot of stuff. It is a problem of centralization and decentralization of data processing and data analysis. And you can see on this slide that this issue, it was highlighted in the paper Centralized versus Decentralized Computing that was issued in 1983. So you can see here that it is more than almost 40 years computer scientists already discuss how to process the data and how to organize the data distribution between the nodes and distributed systems. Prior to the 70s, the centralized model was the top method to organize data processing, because telecommunications equipment, it was very, very expensive. And most of the computer systems, they were huge mainframes that provided services to a lot of users by providing data computing in centralized manner. The consumers of the computing resources, they took their applications, they took their programs to the mainframe, and then the mainframe processed their programs and their data, and they got back with the results of this data processing afterwards. 80s and 90s, emergence of time division systems and remote terminals, they started as an impulse to the client-server paradigms of data processing. So we can see in 80s and 90s, the data processing started to change. There was not only one mainframe who could process the data. Each of the users of this mainframe had his own computer. So he could either process his data on his own computer, but they were very, very low powerful, not very powerful computers. So he could send the data to process it on the mainframe and get this back, or they could use their own mainframe, their own computing node to process the data. So that was the beginning of client-server paradigm of data processing. So what is client-server architecture? According to the paradigm of client-server architecture, one or more clients and one or more servers together with the base operation system and environment interactions form a single system providing distributed computing and data analysis. So according to this paradigm, let's go and draw this. One or more clients and one or more servers. We speak about much less amount of servers comparing to the amount of clients that they provide their services. So we can see here that these clients and this server, they are connected, but clients are not connected between each other. They all are connected to the servers. So the servers can provide their facilities and services to these clients. Together with the base operation system, or as we call it here, the middleware. The middleware allows clients and servers effectively communicate with each other. This middleware provides a common media for interaction. On our previous lectures, we discussed about the possible stack of the communication protocols that allow us to organize such communication. And today, mostly, we use TCP/IP stack of the protocols to organize such communication between the clients and the servers. So together with the base operation system and environment interactions. So environment interactions in this case, these are connections using these TCP sockets between the client and the server. And they form a single system providing distributed computing and data analysis. That means that from the point of view of the user of this client-server system, they form a single coherent distributed system. The user of distributed system or client-server architecture, they commonly do not understand that they are working with the distributed system. If all works as it is intended, that means that the user of the end machine, the end user, it thinks that it is communicating, that he is communicating with this machine on the end, not directly communicating with the server. So it is very simple if we want to organize connection between the machine A, that is a client, and machine B, that we think and we see as a server. But when we start to develop a client-server application, we need to decide how to divide the application functionality between the client and the server. Which parts of our application would work on our client side, and which parts of our application would work on our server side. This is not so trivial question, because a lot of applications, they have very complex application domain logic. So if we draw here a diagram of classes that represent different application domains, objects in our system, for example, we are working and we are designing an application to work with the taxi service, okay? So we would like to organize our application to work with a taxi service. And we have several objects that we need to share between our client and our server. This is client information. This is driver's information. These are tariffs. These are trips. And so we see here that there is a very, very complex structure, and we need to decide which part of this structure would be stored and processed on the server, and which part of this structure would be stored and processed on the client. Right now, I draw some first approach to the distribution of the data processing of these objects on the client and the server. But in reality, this is not so simple. It is a much more complex task. So when the developers understood that there is a common problem with the clients and servers, that we need to understand how to share the data between them, one of the common approaches arrived, and we would discuss this common approach today by the common three-layered client-server architecture. So 3 layers or 3-tier client-server architecture describes a common vision about how the processing of the data and working with the user interface should look like from the point of view of the client-server system. So in the logical multi-layered architecture for a client-server application, the following 3 layers are the most common. And when designer provides this 3-layer application, he provides this implementation of these 3 layers. First, it is a presentation layer or user interface layer, or as how do you like to call it, or a view layer. The second is business logic layer, or as some call them, application data processing layer. And the third is data layer. These three layers are the most common to organize client-server interaction. And when you write your client-server application, you should think how to distribute the functionality between these 3 layers, and afterwards to think how to distribute these layers between clients and several layers of servers. So 3-tier architecture is a client-server software architecture pattern in which the user interface or presentation, functional process logic or business rules, computer data storage and data access are developed and maintained as independent modules, most often on separate platforms. So in 3 layers client-server architecture, we think of interaction between our client and the server not as interaction between 2 entities, but as interaction of 3 entities. The client that represents the presentation, the server that represents the business logic or application server, and the third server that works directly with the business logic server or the application server, the data layer that process the data and that stores the data and provides access to the data. So on this slide, you can see the common 3-tier client-server application. So on the presentation tier, we see and the developer provides the topmost level of the application, that is the user interface. So the user interface is the main function to translate tasks and results to something that user can understand. If we analyze the most common ways to organize the user interface today in the most popular client-server architecture applications, we would see that the most common way today to organize the user interface, it is a web interface. It is a web interface. And the web interface we can create using such tools as JavaScript, HTML, and CSS. These tools are the tools that work inside the web browser on the client machine. So we can see that the most of the user interface today is implemented on the client machine. The next tier, it is logic tier. The logic tier coordinates the application process, commands, makes logical decisions and evaluations, and performs calculations. So the logic tier, it is implementation of the business logic of the application. And if we continue to speak about our web applications, the logic tier commonly today implemented using application server. Application server, we can use different approaches to organize this application server. Mostly, if we would like to create some simple web application using this 3-tier client-server architecture, we can use such tools as PHP. It is a language and an application server. If we choose another language, we can choose another application server to organize this. For example, if we use Python, then we can organize our application server using such a tool as Django. Or any other language. The feature of this application server is that they are running, these application servers and these languages, they are running on the server machine on the web. But this server machine should not work as a data storage, because it would provide big disadvantage to the data processing of the user's requests. So the next tier that we are discussing today here, it is a data tier. And the data tier provides us with the capabilities to store and persistently store the data, and to form some vision about how this data is mirrored to the business logic. So the data tier commonly implemented on the database server. Database server. And if we're talking about some technologies that are most commonly used today, if we are speaking about some monolithic client-server applications, when we have very, very narrow amount of functions of these applications, they're very, very specialized applications. So then we can use SQL or SQL databases to store our relations of the data and organize the most common language for our logic tier components. If we're storing some information for microservices or very, very small client-server applications, we can use NoSQL, NoSQL databases. SQL databases, you know, like MariaDB. I would not write it down. It is very hard to write with the mouse, you know, here. Or MySQL or PostgreSQL. If you don't like to organize these relations between your data, then you can use NoSQL databases like MongoDB, for example. So let's go and discuss more deeply about these three layers of client-server architecture. The presentation layer or user interface layer, typically it is implemented on the client. At least some part of this presentation layer should be implemented on the client, because this presentation layer provides methods for interaction with your application. And if client would not implement any of these presentation layers, then there would be no way to interact with your application from the point of view of the user. So on the presentation layer, if we develop it for the personal computer, for the laptop, we can use native user interfaces for Windows, for Linux, for Mac OS. We can use common web interfaces. So we launch the browser, and the browser takes a role of the implementation of the most of the presentation layer using, as I said, JavaScript, HTML, and CSS. If we create our client for the mobile device, like this one, then we should create it using the languages and the platforms that are provided by the mobile device platform developers. Like iOS, then you should use Swift, or you should use Objective-C, or if you use Android, then you should use Java to create your user interface. The point of the user interface is to translate the user's interaction that would be created using mouse, keyboard, or touch interface to some commands that we can send to the server. This is the minimal crucial part that the presentation layer should implement. And backwards, the commands from the server should be able to be visible to the user. So we should provide this user some feedback. The simplest solution and the simplest option to the presentation layer is a character display or the terminal to the mainframe. When you open the console and you see inside the console the console and the blinking cursor here, that means you're ready to use your simple user interface, and this user interface is a command line interface. So when we are talking about the simplest solution to the presentation layer, it is the character display. And the most common solution today that is much more effective than the character display to the common user, it is a web page of your web application that is running in the web browser. So this is the presentation layer. This layer, it takes the user input, sends it to the application layer, and gets the result of the processing of the application layer back to the user. So the user could see what was the results of his interaction. Next, it is business logic layer. The business logic, it is a set of rules, principles, and dependencies of behavior of the main objects. The synonym of this business logic is domain logic. For example, I think a lot of you encountered this issue last weeks or months. Let's imagine that we are developing a system that handles the booking of the airplane tickets. And this system provides some domain logic for the airplane tickets server. So the user, using some kind of user interface, it can be using his mobile client, or he can use his web client, or if he is a corporative user, he can use some specific command line terminal to access this server, application server, for the booking of the flights. So what functions this application server should provide, and what objects should we work with when we are working with booking of the airplane tickets? Of course, the simplest things that we can imagine here, it is an instance of the ticket, an instance of the flight, like the airports, some timetables, and we should have some actions. So, for example, when we book a ticket, then we find the flight in the timetable from airport A to the airport B, and we connect this ticket with the customer. So the ticket, it is a connection between the customer and the flight, for example. And when we book a ticket, we make this connection. But when the user would like to cancel a ticket, Then we need to break this connection between the user and the flight, and also we should make a refund of the money that the user paid us. This is the elements that we need to think and that we implement on the application server here. As you can see, this is all the brains of the application. They are implemented here. All the features, all the brains, how the application works, how it manages different events. I want to book a ticket. This is how you manage. I want to refund a ticket. This is how you manage. All the time of my flight was changed. This is the notification of the clients who are participating on the flight. So the business logic layer handles this. Everything that the application should do, all the verbs, they're implemented on the business layer. Other examples: calculation of the salary plus taxes. This should be implemented on the business logic layer. Evaluation of the quality of education based on the students' evaluations. This should be implemented on the logic layer. Rejection of the hotel upon the race cancellation by the airline. This also should be implemented on the business logic layer. So all the use cases, they should be implemented here on this business logic layer. And the next layer, it is the data layer. The data layer provides the data processing. It implements data preservation. That means that when our application is closed, the data should not be lost. Because if we lose our data every time our server would be closed, that means that we would have no effective way to store the data of our users, of our flights, of anything else. This is data preservation. We need to have the data consistent on our servers. And the second, it is data integrity requirement. The data layer should be responsible for the metadata checking. The data layer should be responsible that the data is consistent and that in our system we have one representation of each user, of each ticket, of each flight. Because if we would have an evil doppelganger of the same user but with the different tickets and with the different flights, we would not understand who of them are real person and who of them are fake. So the data layer should be responsible for the integrity of the data that are stored and processed. It can be implemented, as I said, by relational database or NoSQL database if you implemented your application in the way of microservices, for example. The history and types of the client-server architecture. As I said, the three-layered client-server architecture, it is the most common vision of how the client-server architecture should be organized today. But it's not the only way to organize the client-server architecture. Of course, the most simple way to organize the client-server architecture, still it is two layers of the client and server. So we have the client, we have the server, and we need to understand how to divide user interface, application logic, and data storage between the client and the server. So this is what about this part. So the first way to organize the client-server architecture was the remote terminal architecture. And it is still one of the ways to organize this. When you connect to your remote machine that is installed somewhere in the cloud, you would use this remote terminal architecture. When you open the terminal on your machine and you enter the commands on your machine, and these commands are sent to the server where all the business logic and data and everything is implemented. So it can be synchronous or asynchronous communication. There is no application logic whatsoever on the presentation tier. And the presentation tier provides minimal processing of the data, almost just getting that you typed on the keyboard and sending it piece by piece, character by character, to the remote system. And the remote system gets it all. It is an intelligent server, it provides all the application logic, and it provides all the processing of the data. Remote terminal used today not only to provide access to remote servers for work, it also become clear that today we can use it for example, for gaming. Such platforms as NVIDIA, I think it is GeForce Now. Do I have? I cannot type here. No, I cannot type here. Unfortunately, yeah. NVIDIA GeForce Now or Google Stadia. If you Google these platforms, you would see that they use the same vision of the remote terminal architecture to provide users with the great experience of the cloud gaming. How it works? It is very simple. User has a presentation layer on his machine. It can be either PC, laptop, or even mobile device. Presentation layer implements two responsibilities here. First, it takes the user input. This input, it is keyboard strokes, it is mouse movement, it is touch presses on the mobile device. And this presentation layer sends all this data to the server. And the server implements everything here. The server draws the video stream of the game. It is a game here. As we stream this lecture now, the remote server streams the gameplay for these inputs of the user. The user presses the button up. It sends this button press to the server. The presentation, business logic, and the data layers, they process this up press, and inside the game the character jumps. So the video, how the character jumps in the response of the input, is sent back to the user as a stream. And the presentation layer here should draw or render this stream to the user, to his eyes. Take data from his hands, draw the results to his eyes. This is what remote terminal architecture implements today in the case of cloud gaming. Next, it is two-tier architecture. And this two-tier architecture was the most common way to organize the client-server system from like the year 2000 till 2015. So in the two-tier architecture, we speak about big client applications. And these applications implement all of the presentation tier and all the business logic tier. So these applications are big. They know how to draw everything to the user, and they take responsibility to all the business logic. The most common way to organize these applications was the implementation of the native Windows applications using, for example, C#, .NET, C++, Delphi. And these applications, they worked with a direct connection with the data layer that was implemented using one database server. So this application worked like this. The user launch this application. It gets all the user interface here. And when he wants to get some data, application sends the request to the SQL server. The server processes this request and sends back huge amount of data. For example, tables of data. And this application knows how to process this data and how the business logic works. So each instance of the client knows his own business logic. In the terms of two-tier architecture, these kind of clients are called rich client in terms of the capability to work with the data. This client handles almost all the application logic, and this client holds almost all the data processing. The data, the second tier, is implemented using database server that's responsible for some certain data processing using some SQL, and it holds one connection per user. So that was the most common way to organize things in the thousands. And it is not the only way to create rich clients and thin clients that we discussed. That was just one of the most distinct ways to organize thin client as the very, very thin client, and the rich client as the thin client as the very, very thin client, and the rich client that is the very, very rich client. But we can see here that thin clients, it is the type of the clients where it implements a part of the user interface or a user interface and some small part of application interface. But the most data processing and storage is implemented on the server. Then we call this client a thin client. But if the client implements all the user interface and all the application interface, or even maybe some kind of database on his own, then we call this client rich client. And then the server part becomes not so crucial. It just creates the storage or synchronization between different clients. Unfortunately, there are some big cons in the implementation of two-tier architecture, especially rich clients architecture. First, these are extraordinary expenses for maintenance of workstations that we need to handle the business logic. Because the rich client here holds a huge amount of business logic. It provides big data processing, not big data, but some data processing. And if we're talking about big system, for example, when we are working with the students inside the university, and when you search a request to find all the students that was born in the year 2000, that means that your client should process and should draw and should find and should get all the information from the data about thousands of students. And this is a CPU intensive task. So the maintenance of workstations that work with this data, it is crucial. Second, it is difficult to update the application when the business logic changes, because we need to reinstall all the clients at once. Because the application logic is implemented not on the central server, but on all the clients. We cannot just update the server and say, okay, we updated the server, you just run, you just close and open, and that's voila, that is your new application. If you change some kind of business logic, then you should update all the clients in the part of your two-tier application. And that means that you need to go to every client and you should say, okay, now you stop, you're not working, you should close the connection, I would update this. And you should not try to implement anything while this is updating, because your business logic would be broken and the data that you would send to the data store would be broken, and everything would be broken if you would work in the time of the system update. That is very hard to maintain, very hard. And next, each workstation is a unique set of software. That is one of the crucial points why these rich client applications are going to the history. Because when you create your rich client, you need to use all the capabilities of the operation system that is implemented on this machine to draw, to process data. And if you use Windows, then you use Windows applications to implement this application logic. If you want to use Linux, you need to create a special application for Linux. If you use Mac OS, you need to create special applications for Mac OS. If you use, for example, mobile clients, you need to use a special application for mobile clients. So when you create rich client, you stuck to the unique set of software and platforms that you would be ready to support, and other platforms and other users would be out of boundaries. They would not be supported. If our edu.susu.ru was implemented as a rich client, let's imagine this. That means that all of you would not be able to participate in this chat right now, in these tests right now, because it would be strictly prohibited to work with this platform from outside of the network, because it would be very hard to establish the connection. And you all need the same operation systems. You would not be able to work with this system very easy from the mobile client, because you need to create your own big implementation for this. But when we go from these rich clients to the thin clients that implement only user interface, especially in the form of web interface, everything becomes easier, especially working through the internet. Because just right now, you are sitting, I don't know where do you sit. I don't know where do you work from. What machine are you using to listen to my stream? Because everything that we are using right now, it is web. It is web interfaces. And they are using this approach of thin clients and common middleware to implement clients to all this stuff. And for example, edu.susu.ro also implemented using these web interfaces. So that is the way of three-tier architecture. When we have presentation layer, we have business logic layer, and we have data layer. And the user contacts the presentation layer, where we have UI logic, very, very simple part of the logic. For example, if you provide your email and the email do not correspond to the common emails, then UI logic would tell you, you know, here in this field you should write your email, but you wrote something else. There is no @ sign. Please write your email there. This is the presentation logic that can be implemented on the presentation tier. Business logic, it is application server. Everything is implemented on the business logic. It is processing business logic. It is high volume processing, CPU intensive tasks. And the data storage is implemented using the data layer, the database server. It reducing the connections per user. So right now, not each user connects directly to the data store. No. User connects to the business logic, and the business logic can handle most of requests without going directly to the data store. If we need to go, then he asks, and we decrease the connections between the presentation and the data store layers here. So we can see here an example of application layering using the simple diagram how some web search interface can work. We have user interface here, and the user can enter the query to the user interface, for example, find pictures of nice kittens. And this keyword expression goes to the processing layer, to the query generator, and this query generator creates the database queries for the nice kitten pictures. The database with the web pages analyzes these requests and sends back the web page titles with meta information to the processing layer. The processing layer implements the ranking algorithms, creates the set to the HTML generator that creates the HTML page to the user interface, and the user would see the list of the most relevant pages with the most beautiful kitten pictures. So the summary, that is very simple. There are three tiers in the client-server architecture: presentation layer, business logic layer, and the data layer. And if you create your system that is implemented using these three layers, you can distribute these three layers as between two computers. Then you create two-tier architecture, but then you need to decide what would be implemented on each of the machines. Or you can implement it as the three-tier client-server system.